Good morning, class. It's bright and early. I'm up here at the high school at about 6 o'clock this morning, putting this together for you. So I hope you pay attention, learn a lot, and enjoy the presentation, because it's going to be very useful, especially when you see how it relates to the graph of a parabola. And again, we'll be using GeoGebra today to graph our products and see how it relates to the parabola. So sit tight, relax, and enjoy the show. Alright, so let's look at number 1. We're on page 354, section 6.5, how we multiply polynomials. So my first product is an example of multiplying binomials. So the first step I want to show you is that let's use the distributive property. So we know that if we were to cover up the x term, we end up with just positive 2, and multiplying by positive 2 using the distributive property would give us, I'll show all my steps, okay? So this would be 2 times quantity x plus 3. So we're going to multiply that out, okay? That would be the first step using the distributive property. Plus, right? Now we're going to add plus. Right? That's what this means. To add what? Well, now we're going to add the next product, which is that. It's the x term being multiplied by the quantity x plus 3. And so, let's work this out. Again, I just showed the product. 2x plus 6 plus x squared plus 3x. Okay, let's write this in standard form. Combine like terms. Those are my like terms. The degree is 2. So in standard form, my answer is x squared plus 5x, and the constant is 6. It's one way of doing this. Example or question number 3, I will use the FOIL method. So using the FOIL method, that is first, outer, inner, last, here's how this plays out, okay? So this is our first term, right? First term in the binomials, right, is 2x and x, so I will write that out. It's 2x times x plus outer term. Now, the first outer term, the outer term of the product. And so that would be 2x and negative 6. Okay, when you subtract by 6, you're adding by a negative 6. So that would be plus 2x times negative 6. The inner term of the product is 13 times x. And then the last term of the binomial, two binomials, is 13 and negative 6. Multiply those. So there it is. I multiplied the terms. And let's combine our like terms. And so the polynomial written in standard form is 2x squared plus x minus 78. We also know that the degree of the polynomial is 2, the constant is negative 78, and the leading coefficient is also 2. All right, now, the last question here, let's use a generic rectangle to multiply this out. In other words, it's a lot like using algebra tiles. Okay, so let's use that method. So here's my generic rectangle, and here's how you multiply polynomials using this method. So you look at the first term that you are multiplying the polynomial by, and this expression here, 2x to the third power, will become the first term that is written on my generic rectangle, and this will become the height of this generic rectangle. You can call it the width or the length. Now the next three terms become the next three segments that combine to make up the total length of this rectangle. So 2x squared is the length of this segment here. Okay? And this segment here is 2x to the third. See what's going on? The negative 9x, right, would be here. Now you might think, oh, it's a negative number. How can that be a length? Again, this is generic, not a literal rectangle with a length of a negative number, but it's generic. Okay? And then 3 would be this quantity here. Okay, so I break up each of the terms and use them as the segment length of this generic rectangle. Now, we know that we can find the area of a rectangle through multiplication, length times width. So let's do this. Let's find the area of the first rectangle here. So 2x to the third times 2x squared. So, just to show the process, 2x to the third times 2x to the second. Now 2 times 2 is 4. And x to the third times x to the second. We have the same base. So what do we do when we multiply powers? We add the exponent. So it would be x to the fifth. 3 plus 2 is 5. So this is the area of the first section of your generic rectangle. And so the next section is, again, length and width. It's 2x to the third times negative 9x. So 2 times negative 9 is negative 18. X to the third times x, same base. So the powers of the same base, you add the exponents, 3 plus 1. Remember, a variable has an exponent of 1, right? Single variable. So that would be x to the fourth. Okay, and that's our next area. Then the final section is 2x to the third times 3, which is 6x to the third. And so the total area of this generic rectangle represents the product of these two polynomials. And so the product is, let's combine them, 4x to the fifth plus negative 18x to the fourth, which is identical to saying that you're subtracting 18 to the fourth. 18x to the fourth. And this is a positive 6x to the third, which means you're adding 6x to the third. And that is the product of these two polynomials. So that's using the generic rectangle method. And last questions that I'll work out on this video are here. So let's just use the distributive property / FOIL method. So I will take 2x to the fourth, multiply by 6x, (2x to the fourth multiplied by positive 4x squared). Again, always adding the terms, right? Adding the terms that I'm multiplying by. And keeping the sign of those terms. Plus negative 5x squared times 6x. Plus negative 5x squared times 4x squared. Okay. Simplify this expression. 2 times 6 is 12, x to the 5th. Right? You're adding the powers, adding the exponent. 2 times 4 is 8. 4 plus 2 is 6, x to the 6th power, plus negative 5x squared. So, it's identical to saying negative 30, right? Negative 5 times 6, or minus 30. And second power, first power, 3. Plus negative 5 times 4, which is negative 20, minus 20. And we have x to the 4th. So, it looks like for an answer, anything that we can combine, 5, 6, 3, 4, nope, let's write it in standard form. So my largest power is 6, so this would be 8, x to the 6th power, plus 12, x to the 5th power, minus 20, x to the 4th, minus x to the 3rd. And I'll stop there. The remaining questions will be done at a later date. So, like I always say, we'll see you soon. Study hard and learn a lot. Bye-bye.